Washington State University. Go Cougs!
Hello everyone, in this video I'm going to cover lesson 3 of the Python for Data Analytics module, where we're going to talk about the SciPy ecosystem and begin our discussion of Numpy. SciPy is a collection of open source software for data science, math, and engineering. Some of the core packages include NumPy, SciPy, Matplotlib, IPython, SymPy, and Pandas. We're going to cover all of these packages in this module except for SymPy. We won't talk about SymPy. So let's begin our discussion with NumPy. NumPy is the fundamental package for scientific computing with Python. One of the most powerful features of NumPy is its n-dimensional array object called an ND array, which supports really great functionality like vectorization and broadcasting. So without any further ado, let's start talking about the ND array. So NumPy is typically imported as NP. This is how we're going to gain access to creating and working with the ND array object. So import NumPy as NP. Now let's take a look at how we can make an ND array object. Let's start with a list, since we are quite familiar with lists. So I'm going to make a list of, let's do 10 numbers, 0 through 9, and print out the list. Here are our 10 numbers, and we see the type of X is a list. Now let's create an ND array object from X using the function array, passing in X. And we'll do the same thing where we're going to print out X and its type. So we see the same values, except there are no commas in between the values. This is an example of pretty printing that we get with ND array objects. We'll see another example of this here shortly. Looking at the type, we see that this is in fact a NumPy ND array object, not a list. Now let's move on, and instead of one-dimensional ND array object, let's make a two-dimensional ND array object. And obviously we don't have to stop at 2, we could go to 3 or 4, etc. dimensions, but we're just going to start with 2-dimensional today. So let's go ahead and make another list. This will be a nested list, so a list of lists. Let's have 2 lists in our nested list X with 1, 2, 3 in the first row and 4, 5, 6 in the second row. So this is going to be a 2x3 nested list essentially. And we can go ahead and print out X, and there's our nested list there. Now let's make X into an ND array. And this time if we print out X, we see it's an ND array object, we don't see those commas, and we see that it's nicely formatted. So this looks more like a matrix, more like a structured, two-dimensional piece of information. We have rows like 1, 2, 3, and 4, 5, 6, and we have columns like 1, 4, 2, 5, and 3, 6. So let's explore some of the attributes associated with an ND array object. So we could do x.ndim. This will tell us the number of dimensions associated with X. We could also do x.shape. This will tell us what those dimensions are. And let's also find out what the data type is of X. So I run this, we find out this is a 2-dimensional ND array object. Those dimensions are 2 rows by 3 columns, and these are going to be 64-bit integer values. Now it's worth noting that every item in an ND array has to be of the same data type. If we ever need to convert our data type of our ND array to a different type, say a float, we can do so with np.asType. So let's have a new ND array object called xFloats, and we'll assign that x.asType np.float, and we can go ahead and print out xFloats and the type of xFloats. Scroll down a little bit here, and we see decimal points after each one of our values that we didn't have before, and this is still an ND array. So we can check what the data type is for each item of our ND array with the dType attribute. And there we see float 64. Now we've been starting by building our ND arrays with lists, Python lists, which is an unnecessary step. We can directly construct ND arrays with Numpy functions. So say we want a sequence of numbers, we could generate these using range and then converting to a list, or we could use the Numpy arange function. So let's have x be assigned np.arange, and let's stick with our 10 number here, and let's print it out. So there are 10 numbers 0 through 9. If we ever need to have perhaps all ones or all zeros or all of one value instead of these sequential numbers, we could do so with special functions in Numpy to build these ND arrays. So let's do x2 is assigned np.ones, and let's get 10 ones, and we'll print out x1, and there are our ones right there. Note that those are floating point numbers, not integer numbers. Similarly, let's build an array of 10 zeros. There are 10 zeros, and say we don't need ones or tens, we need some other arbitrary number like 5s. Well, we can do that with the full function. So x3 gets np.full. We want 10 numbers, and we want them all to be 5s. And there we have it, all of our 5s right there. Now, there are additional arguments that we can pass in to all of these functions. Remember, you can use the help command to find out about how to use a function or a method. For example, say we didn't want to start x at 0, maybe we want to start it at 5. Well, we could specify a starting value there, which we can find out how to use that with a simple call to help on np.arange. And there we see our start, stop, step, and we can specify a data type. So start, stop, and step, these are going to be in the same order and have the same functionality as you would expect from the built-in Python function range. We can index into an ND array object just like we would do so using a standard Python list. So let's have our typical example we've been working with, 10 numbers 0 through 9. And let's go ahead and print out x and print out, say, x sub 3. So the item at index position 3 is in fact 3, 0, 1, 2, 3, and there we print it out. So let's do another example, but this time with a two-dimensional ND array. So let's build a 2 by 3 ND array of 1s. Let's see what it looks like. Okay, there's our 2 by 3. And say we want to print out the first one in 1s. So index once to get the row, index the second time to get the column. And there's that first one. We can also do this with commas. So 0, 0, and get that first 1 as well. ND arrays are mutable, which means we can change them, we can update the values. Let's see an example of how we can do this. For this example, we're going to utilize some random data, and we can generate random data in the structure of an ND array using the random function. So we'll go ahead and import the random function from numpy.random. And let's create a 3x4 ND array object of random data. Let's see what that random data looks like. Okay, so there's our random data. Using assignment, we can update one of these values. So let's update, let's say, the second row first item. So that'd be that negative 0.49. Let's set it to be something outrageously high compared to these other values like 100. And let's print rand data to see that update. So what was originally a negative 0.49 is now 100. But rerunning this, it's now negative 1.29. We set it to 100. Okay, so let's do a little exercise here where we're going to replace all of the negative values in our random data with zeros. So first, we need to find out where are the negative values. So this will give us a Boolean array, which is really cool. So it's going to build a same shaped ND array where a Boolean is going to be stored whether this value is less than 0. So for example, 2.04 is not less than 0, so false is stored there. Now let's go ahead and set rand data sub negatives. So this would be all of the true values to 0. And we run this. So here's an example. Column 0, row 1 is negative 1.29, and now it has been set to 0. So Boolean arrays are really powerful and really useful. Last topic here is let's talk about slicing. So slicing with ND arrays is similar to what you know about lists, but there is one very, very important difference that I cannot emphasize enough, is when you take a slice of an ND array, you're going to get a view of the data in that slice, not a copy of it. And this is for optimization. ND arrays are expected to store really, really large amounts of data. So every time a slice is taken of an ND array, to save on time and space complexity, there's going to be views returned of the ND array, not copies. So that means if you modify data in a view, that's essentially an alias for your ND array object, you're going to be modifying that ND array object in memory. So let's take an example. Let's build a list of 10 numbers, and we will go ahead and print out this list. Okay, there are 10 numbers. Now let's take a slice of this list. We'll call it chunk. It doesn't really matter where we slice from. Maybe we'll go from 3 to 7. And we'll print out chunk. So I want to emphasize that chunk is a copy. So if I set chunk sub 0 to be 50, and then I print out chunk, and I print out xlist, then I see the first item in chunk is 50, but the first item in xlist is not 50. So summary, a slice of a list is a copy. Now let's do this same code, but instead of working with Python lists, we are going to work with NumPy ND arrays. So let's do np.arange10, print out x. We'll take a chunk, again, take the same slice, and now this is going to be a view. So we'll set chunk sub 0 to 50, print out chunk, print out x. And let's see how the output differs. So here, chunk sub 0 is 50, and if we look at our ND array, we see ND array sub 0 is 0, but ND array sub 3 is 50, which is different than the output when we were doing the same code with lists. So definitely something to keep in mind. The workaround for this is if you ever do really want to copy from a slice of an ND array object, then go ahead and just call the copy method from an ND array object. So let's just go ahead and copy this for this example. So here, if I have x sub 3 to 7 dot copy, then chunk actually is a copy. And if I run this, we see that x sub 3 is actually 3, not 50, which was chunk sub 0, the slice starting at 3.